Hello and welcome back to CCNA 3. We're going to talk about queuing algorithms in 9.3. Now, if you haven't watched 9.2, I highly recommend you watch that and make sure you have an idea of the different types of traffic we're going to prioritize and why. And now we're going to get into actually how we're going to prioritize that traffic with these algorithms. So really, it's going to be something that we're going to do as admins or engineers. We're going to configure this so when congestion occurs, not if, when congestion occurs, we're going to be able to prioritize what's important. So queuing, we're going to put everything into a buffer, a line, and it can wait if we don't have enough bandwidth on that link. If required, we're going to reorder packets before being transmitted to the destination. And so we have quite a few algorithms, more than just these, but these are what we're going to learn about. We have first in, first out, which is usually the default, right? It's a basic, simple line like you would see maybe at a drive-through. So you're going through the drive-through. If you drive up first, you're going to be served first, etc., etc. Sometimes drive-throughs will do weird things if you have a really big order or an odd order, where they'll have you drive up and have other people go through. But we're not going to think about that right now. Just basically, if you show up first, you get served first. That's how it works. Weighted fair queuing is going to be more like an airport checking line. So you'll have your regular average Joes, like me, I'm poor. You'll have your priority or priority, I can't spell. You'll have your priority customers, and so you'll pick a line that is relevant to you, right? And you have to have some kind of identification to get in that priority line. You have to have some kind of rewards member card or something like that. I don't know, whatever they do. I'm not that fancy. I don't fly often either. Again, the poor part comes into play. So we have a few different options, and they're pretty standardized across the board. Then you have class-based weighted fair queuing, which to me works more like boarding a plane. So it's a lot more complicated than just a few lines, right? We have, first of all, we're going to allow our premium members, I might have spelled that wrong. Then we're going to maybe have veterans. Maybe then we're going to have some other class, maybe people with children. Maybe then we're going to have group 1. Maybe then group 2, right? And of course you pay more for your group 1 ticket than your group 2 ticket, and blah, 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 and all this complicated stuff that I don't get into because I don't really care. Anyway, so they'll have this kind of, this hierarchy here that can get awfully complicated actually sometimes. I don't know if you guys fly often, I don't, but the few times I've gotten on an airplane, they're like, yes, and if you have a purple luggage bag and a blue shirt and your name is Tom, then you can board now. And I'm like, well, my name's not Tom, so I kind of I'm not in that group, yeah. So it can get really complicated, and it's really per airline more, right? The weighted fair queuing, that's more just general. Everyone does the same thing. However, the class-based is going to be customizable. It's going to be per airline. It's going to be per customer. It's going to be per organization. So our organization may put veterans up here or people with children up here, whereas other organizations might not care about putting people with children or vets on the plane first. They may just say, hey, if you're premium first, and then group 1 and group 2. It just depends on the organization's wants and needs that they're going to choose those things. And there's also low latency queuing, which we're going to talk about as well. First in, first out, again, very, very simple, right? First guy that gets there, gets out first. No priority, no classes of traffic, no decision about packet priority. There's only one queue. All packets are treated equally. Very, very simple. This is the default in most cases. Just whatever comes in first gets there first. Weighted fair queuing. Again, we're going to have some basic priorities and we're going to classify them into conversations and allocate bandwidth relative to other flows. So the flows are based on source and destination IP address, MAC addresses, port numbers, protocol numbers, and type of service values. Now these can all be found in your packet header. So the one we're really concerned about in QoS is this type of service field here. And this, by the way, I should have let you know, this is a IPv4 header, right? So we're talking about layer 3. So all these addresses here, they're going to be IP addresses, right? And of course, we'll also have a layer 2 header for our source and destination MAC addresses. But let's just keep in this little world, and I will remind you of some things with our header here. So we actually have the data. This is actually what we're transmitting. Everything else is going to help us in the transmission of the data, right? We have the IP version, so version 4, version 6. We have different protocols we can use. Within there, we have a time to live value, which is going to prevent us from having an infinite loop, right? If we have 3 routers here and the packet is for some reason going around and around and around, this time to live will eventually expire and then the packet will be dropped. Other flags we can add, checksums, other things we have here, total length of the packet. But really in QoS, what we're going to talk about is this type of service field. Very, very important. So, and that image was from Wikipedia, if you're interested in finding it. And it's just what pulled up on Google. It's just, there's a million of them. So the flows are based on source and destination IP addresses, MAC addresses, port numbers, and protocols, right? And this type of service value, very, very important right here, type of service value. Weighted fair queuing is not supported with tunneling and encryption because these are going to modify the packet information. So remember, when we tunnel something, we're actually going to have the actual IP header here. And we're going to put on maybe a GRE or IPsec or both headers on top of it. So it's actually going to read this information of the GRE tunnel, not the actual header. So if we have voice over IP traffic and TCP traffic for a website going over the same GRE tunnel, then we're not going to be able to differentiate them with weighted fair queuing. Now we're going to be able to classify different types of traffic and prioritize them accordingly, right? So purple is probably your voice, medium is probably your video, normal is probably most other things, and then low is probably things we really don't care about, like YouTube or Facebook. at our place of employment, maybe. Just an example. And let me just clarify over here. You'll see that everything is reordered. We have the high priority first, the medium priority second, etc., etc. So class-based weighted fair queuing is going to do the same process with weighted fair queuing, except for we can match including protocols, access control lists, very, very granular we can get with these access control lists, and ingress interfaces. So traffic is assigned accordingly, and then we have a queue with each class that is within that queue a first in, first out queue. So we can have a ton of different characteristics such as bandwidth, weight, maximum packet limit. The bandwidth assigned to a class is guaranteed bandwidth. This is great for voice, but not so great for bursty types of traffic like video or data. So really with most of QoS types, you're going to prioritize voice. That's the most important thing we want to prioritize. Voice is consistent, and voice is English is hard. Voice is consistent, and we can expect the size of the voice packets, we can size the consistency, how often they come, everything. So it's a lot easier to prioritize that, and it's the most important to prioritize. So different classes are subject to bandwidth and queue limits, which limits the maximum number of packets allowed to accumulate in the queue. So once we've configured that queue limit according to the adding more packets to the class causes either tail drop or packet drop to take effect. So tail drop is going to discard any packet that arrives at the tail end of a queue that has completely used up its packet holding resources. So say you have your queue here, and it's all filled up with stuff, well, anything that comes in is going to be dropped. And that means it goes into the trash bin. So this is the default queuing response to congestion. Tail drop treats all traffic equally and does not differentiate between classes of service because it's already been classified, right? So we've already picked the queue it's supposed to go into, and that queue is full, so it gets dropped. So we have these user-defined classes instead of standardized classes. So maybe we'll have class number 4 go into our highest priority queue, class number 3 goes into our second priority queue, and 2 and 1 both go into our third priority queue. And then we will reorder them accordingly, right? By the queue that they're in. Low latency queuing is going to be very, very strict. This is the most complicated of all. So it allows delay sensitive packets such as voice to be sent first before packets in other queues, giving delay sensitive packets preferential treatment over other traffic. Cisco recommends only voice traffic is to be directed to the priority queue. If you direct stuff like video traffic or other bursty types of traffic, you can have some very, very complex issues. So basically what we do here is we take this user-defined classification service and we slap this priority queue on top. This is our low latency queue right here. And we're going to take our voice packets and we're going to send over here, and they're going to go number 1, and then everything else is going to be classified thereafter, right? We're going to have our highest priority, medium priority, and low priority after we've already sent our voice traffic. So that's it for all our algorithms. And now we're going to talk about QoS models in 9.4. So I will see you soon for that video.